I'm going to do my authentic teaching on connectedness. So that's the topic I'm going to choose. It's going to be another science lesson. We're going to do chemical and physical change. And luckily with chemical and physical change, there are some indicators that help us out to determine which one has taken place. And for chemical change, we have an acronym. It's called AGAPE. Has anyone ever heard of that before?
No.
I know the Greek version that means something totally different, but it's cool.
For A, we have altered molecules. That's one way we can determine if a chemical change is taking place. You know what I mean by that? Just change form into a new substance. Another one is gas formed. So we do something, we can have gas released. A is aroma or colour change. And those are pretty obvious ones. You can smell them or see them. P is a precipitate formed. Well, that's certainly not in English. You guys all know what a precipitate is? You have a liquid, and then you make a reaction, and then you get a solid forming in that. And E is energy released or absorbed. And the things we can determine if energy is released or absorbed, if something gets colder or hotter. For physical change, we have changes in the size or shape, and they're pretty obvious ones to determine as well. We have phase. You all know what I mean when I talk about phase? From liquid, solid, and gas. Yeah.
State.
State, yeah. Same thing.
Yeah.
Density. So how much pressure of something is usually associated with size and shape. If that changes, then usually the density of something will change as well. And texture. So that's if we have something smooth and then maybe we change it and then it gets rough. So we can determine that it hasn't actually been a chemical change, but actually a physical change. And in some cases, it may change color. So now that we have these, and we've got these, we can determine if things are chemical and physical changes. I'm going to give you some examples, and then see if you can use these to work out if it's a chemical or a physical change. So who eats breakfast? Who eats food?
Yes.
What about toast? You guys have toast for breakfast?
Yeah, man.
Yeah. So if we think about toast, what do you think toast could be? A chemical or a physical change? A physical change?
Physical, yeah.
So if you look at these indicators, these factors that would determine a physical change, which one of those could you relate to toast? Cooking toast?
Colour.
Yeah, change colour. So that's
Texture.
one. Texture, yeah.
Density, even.
Density,
I
you
feel like
reckon?
it gets lower.
Alright, so we've got those. They're
I'm
made.
not going to tick off density, okay.
What about if we go to the other side?
Does aroma or colour change?
Do we have altered molecules? If we burn something, do you think we're altering the molecules?
Yeah.
Yeah.
We are.
Yeah.
Yeah. We definitely are.
Yeah.
So we've got one of those. What about gas formed?
Yep.
If
Yeah,
we burn
can be.
something, do we have gas formed?
Yeah. There's an aroma.
Yes, we do.
Definitely an aroma.
Aroma or a colour change?
Yeah.
Yeah, 100%. Precipitate formed, but it's not really for this, but energy and released or absorbed. What did I talk about before when
Heat.
things get hot or cold? Yeah. So now you thought it was a physical change. What do you guys think now? Yeah, definitely. Chemical change. It is. Burning anything is a chemical change.
It's a good example.
So that most forms of cooking is chemical change.
Pardon?
Most forms of cooking is chemical change.
Yeah,
This is
definitely.
all we usually heat it.
Yeah, like baking a cake.
Yeah.
How about baking a cake? Have any of you guys baked a cake before?
Yeah.
Yeah. What do you think is that one?
I'm going to get chemical now.
Yeah, chemical, definitely. Because then we've got altered molecules, we're cooking it, and it's burning, it's changing the molecules inside. Gas formed. What do you think makes a cake spongy and nice and soft?
It's a gas.
That's the gas released from the yeast.
And the, yeah.
Yeah, so it's little bubbles of carbon dioxide. That's what makes it spongy. So we've got that, aroma and colour change. What does a cake smell like when it's cooking?
Amazing.
Pretty good, yeah.
Rainbows.
Precipitate form, that's another one we don't have to worry about. Energy released or absorbed. Yeah, definitely. Alright. Who has a birthday? I'm guessing everyone. I'm hoping everyone. You guys ever blown up balloons on your birthday?
Yeah.
Yeah. What about blowing up a balloon? What do you think that
Surely
could
physical.
Definitely
Physical.
Surely
Right.
physical.
Let's see if we can mark off these things. Size or shape?
Yes.
Yes, definitely. Making it bigger. Phase.
No.
No, not
No,
really.
Not the balloon itself.
No, not really, yeah. About density.
Yes, definitely.
Yeah, definitely. We're blowing all that air in, we're making it bigger, but we're also increasing the pressure inside the balloon. Texture?
Yes.
Possibly, yeah. You first have a balloon and it's really rubbery.
Quite smooth.
Yeah.
Yeah, then you blow it up.
It's stretchy
it's
and then
like
it becomes
really
quite taut.
smooth and taut. Yeah, exactly.
Alright, fair enough.
May change colour.
Yeah, it does a little bit.
A little
It gets
bit,
weaker
yeah.
if it's
You're
like it gets
stretching.
lighter.
Yeah,
Yeah, the colour's
definitely.
more spread out.
So you guys pretty happy with that?
Yeah.
And if we go to the other side,
No, none of that.
not really any of those, is it? No, not at all. Alright, I've got another one for you. It's going to be a tricky one. Have you guys ever seen, you know, the experiment you do, you put Mentos in a Coke bottle?
Yeah.
Yeah, you've all seen that?
Yeah.
Has everyone seen that?
Yeah.
Yeah, it's pretty cool, isn't it? What do you think of that one? Chemical change.
Cool.
Let's tick them
No,
off.
I don't think
Not
it's
sure
chemical.
yet?
I think it's physical.
I'm getting
I'm
it.
suspicious. I'm going to say
What makes you think it's chemical change?
Because it's creating those bubbles and stuff that you just you straight up think that it's making a change in, like, without going through the list, you think it's making a change to the chemical properties of the liquid, which makes it do these funky things.
Yeah. Well, Kieran, you said physical change. What makes you think it's a physical change?
because it's really just a change in form. There's no. I don't know. I don't think it alters the molecule.
It's because I would say the gas is what's doing it, and I would assume that the contact of the Mentos with the liquid is actually interacting with the molecules that creates those gas changes.
Yeah.
So
We've got
that's
two
why
sides here. Let's see if we can look at these and mark them off. Do you think there would be altered molecules in there?
That's what I'm assuming.
Yeah, assuming, but there's not really, no. It's not really changing anything. Gas formed,
Yeah.
Yeah.
you think?
Well, it's releasing
Well,
gas
releasing.
in there.
Releasing gas.
It's
Do you
not
think
true.
Coke already has bubbles in it?
Yeah.
it's
You can't see?
Yeah.
Yeah. So it's not really
okay.
creating gases.
Yeah.
It's not gas formed from... Because usually when gas is formed, it's because of this, because of the altered molecules.
Right.
But you open up a Coke bottle,
Yeah.
there's gas, plenty of gas already in there. Aroma or colour change? Not really. No, it just smells like Coke. Precipitate formed?
No.
Not really.
No.
Energy released or absorbed?
Well, yeah, there is.
Well, that is,
There is energy.
So we'll mark that one. And then we'll go to the other side. About this one. Size
winning.
or shape?
Yes.
Size or shape? Yeah,
Yes.
definitely. Like inside you've got a
That's
lot of
little
Coke.
expanse.
You
Yeah.
put it in.
And then outside you've got a lot of Coke.
Yeah, and then you don't have so much Coke anymore. Phase. We change.
Yeah. It's kind of goes from a liquid to a.
Well, no, we're just releasing it. We're not
Yeah, we're just
creating. We're
releasing
not
Oh
changing
yeah.
it.
Alright, fair enough.
So that's kind of iffy now.
Yeah.
Oh, it could
I think
be
of bubbles as not.
when you're mixing the Mentos
The
starts
Mentos
to
is
get
changing
dissolved
phase.
as well.
Turns into liquid.
Yeah, so we could tick that one.
Well, then I want molecules.
No, put your hand down. This is my
But
turn.
if you're dissolving something,
Yeah.
we'll come back to that. I'll do one
That's
more after
fine.
this.
Yeah, right, okay.
Density.
Yeah?
Yeah.
Otherwise it wouldn't come
100%.
flying out the bottom.
That's where all the pressure comes from.
Yeah.
Texture.
Yes, definitely.
Yeah.
Yeah.
Not really in
go
the
for-
Coke, but on the in the Mentos itself,
The
there is
Mentos
kind
is
of
changing, yeah.
Yeah.
And colour.
May
yes.
change colour, or
Yeah, it goes
It
all
does.
white, comes
that's
shooting out.
because that's just full of bubbles.
Yeah, exactly.
So you shake up your soft drink. Yeah, it's not really the colour of the
It's a
soft
physical
drink.
change. It's not like a
all-
chemical change.
Yeah. So we took that one. So now you've had a rethink of this. What do you think it could be? It's a pretty good indicator. It's physical change, isn't it?
Yeah.
We didn't
Yeah.
know why.
Huh? Yeah, I didn't have a good reason.
I didn't have
What
a-
happened-
Other than I think that we was trying to check out.
What happens with
Yeah.
those when you're doing the Coke bottle is you put the Mentos in. Mentos, it needs to be really fresh Mentos because it has this nice wax
Fresh fruit
coating on
Mentos
it,
tree.
and it's really rough and it has millions and millions of little divots. And you get an old Mentos, it's worn that down, and then you put the Mentos in, and what it does is it tracks all of the carbon molecules. As it's falling down, it's attracting more and more, and then the Mentos is attracting them as it goes down the bottle, and then it has all of the carbon dioxide molecules at the bottom, and you put a whole pack of Mentos in, so you're pulling them down, and it's pulled all of the carbon dioxide into the bottom of the bottle, and that pressure just has to go somewhere.
But it's not changing the molecules.
It's not changing
It's just
them at all. It's just
pulling them.
It's just, yeah.
It's just attracting them. Like there's just little divots for
Right.
the carbon dioxide molecules to fit in.
Yeah,
You're like,
right.
oh, I'll sit here. It's pretty good, but you're not changing them at all
Lazy carbon dioxide.
They are, aren't they?
Trying to sit them down.
until they get together, and then it's a party. All right. So what about? Trying to think of one for dissolving. It's probably not something that you do very often, but putting salt or sugar into water.
Mhm.
About a Barocca.
Yeah, or a Barocca. I don't know if students would maybe have
That's
those.
true.
Maybe
Yeah,
depending
maybe
on
like-
the year level.
Dissolve
they're-
aspirin or something.
Yeah. So if we do those, what do you think that would be?
That's a physical change as well.
Surely.
Physical change. We'll see if we can mark
No,
them
I'm
all.
going to say chemical.
Chemical.
Committing.
Alright.
Physical.
Committed to
I
chemical.
think physical because I think it's just dissolving into the water. It's not. It's
Yeah.
not. It's like
Alright,
putting
we'll
cordial
start-
in water. It's not.
We'll
a
start at chemical side.
Fine.
Do you think we've had? We'll do both. Do you think we've had altered molecules? Do you think we're changing anything with? No, it's just being dissolved.
Just being dissolved.
Yeah. Gas formed.
It can be, because
yeah,
you
it
put
can
it in
be,
water,
yeah.
there's no gas in there, and when
Yeah.
you tend to put in like a
You
bubbly
see the
thing,
bubbles
you-
come off. Yeah.
Yeah.
Fine.
So we
I'll
do
give
have
you
one of
one.
those. Aroma or colour change.
Well, there is a colour change, but that's
Can
just
be.
the.
Depends.
With a
That's
Barocca,
just the
yeah.
mixing together.
Depends
With
if
the
you.
Barocca.
Yeah.
Yeah.
That could just be a dye.
Yeah, well, that's what I'm saying. Yeah.
So we do have that. That's could be iffy, but we'll mark that one. Precipitate formed.
No.
Not really, because we're doing the opposite
Yeah.
of precipitate, aren't we?
I don't think there's any.
Energy released or absorbed.
No, not really.
Oh, there possibly could be a slight energy release formed
With the bubbles.
with the with the bubbles.
Yeah.
So yeah, we'll
Slight.
give that one. Well, this one, size or shape
Of the Barocca, yeah.
of either, yeah.
Of I or both.
Yeah, definitely.
Phase of the
Phase,
Barocca,
yeah.
yes.
Yeah, we're changing
Yes,
that.
dissolve.
Definitely. Dissolving it.
Density,
Density.
of the Barocca.
Yeah.
Texture,
Texture.
of the Barocca.
May change colour.
Yeah.
Water, yeah.
Yes, it may.
Made.
So now we've had to think of that one. What do we reckon?
Well, it's physical all day,
Physical.
mate.
You're not committed anymore?
Well, there's clearly more ticks on that.
So these are really good indicators, but they're not 100%. But obviously, if we have more ticks here, then we have a really good indicator that that's what's going to happen.
So what would the assessment you would do after this lesson?
Oh, God.
We'd go out and do pracs.
Then,
Yeah, and we'd test out these theories.
yeah.
Yeah.
And then it would kind of be like a crack report that they'd submit.
Yeah, or just a worksheet. Yeah, prac report or a worksheet.